Okay, now I'm going to talk to you about the rules of differentiation, and I'm going to teach you how to find the derivative function for some simple functions for now, okay? Well, any particular function, okay? Right, so let's start off with an example. Take the function f of x equals x squared. Its derivative function is just 2x. Now you may have seen how that works, okay? There's a little pattern to it, okay? If I write one more, let's take another function. F of x equals x cubed. Its derivative function is 3x squared, okay? Now how that works is this. If you look at the power's 2 in the function, and what happens is it goes to the front, like it did here, it becomes 2, and then what happens to the power itself is you subtract 1 from it. And what's 2 take away 1? Well, it's just 1. So it becomes 2x to the power 1. And the same thing here. If you look at the original function itself, okay, the derivative function it comes from taking the power, which is 3, putting it to the front, okay, so there's the 3 now, and then taking 1 off the power, and 3 take away 1 is 2, so it becomes 3x squared. Therefore, if we had something along the lines of f of x equals x to the power 4, its derivative function is, well, okay, the power comes to the front, so it becomes 4, and then you take 1 off the power, and then it becomes 3. I really don't need to write that minus 1 actually. You know what, I should not write that there, because that might confuse matters. Okay, so it becomes 4x cubed. And if you had something like f of x equals x to the power 5, its derivative function, f dash of x, equals 5x, and take 1 off the power, 4. Now, what if, you may be asking, what if you just had x like this? What if you just had f of x equals x? Right, so f of x just equals x. Well, think about what power you could technically write there. It's not 0. Technically, if you just had x, there's a power 1 there. Okay? It's x to the power 1. X to the power 1 is just x. So its derivative function, the power comes to the front, and you get a 1. Okay, and then I'm just going to write this in orange. Okay, if you take 1 off the power, I'm going to write it over here. You get x to the power 0. You know, actually, no, I'll write it next to it. You get x to the power 0, right? Okay, x to the power 0. But if you think about it, what's something to the power 0? Okay, what is anything to the power 0? Anything to the power 0 is 1. So it just becomes 1 times 1, which is just 1. So its actual derivative function is 1. Well, if you think about it, this is just a straight line graph, isn't it? This is, you know, f of x equals x is just a straight horizontal line, okay, a 45-degree line, and its gradient is 1 across, 1 up. Its gradient is 1, therefore the derivative function's got to just be 1. It's just got to be 1. Okay. Now let's take some. Let's go a little bit further. What if you had f of x equals 5x? Okay, f of x equals 5x. What is its derivative function? Okay, what is this f dash of x? Okay, I don't know why I've put that little dot there. Okay, well, okay, at the moment the x has got a power 1, and the 1 comes down and it multiplies the 5, so you just have a 5, and then you take 1 off the power, so the power becomes x to the power 0, but anything to the power 0 is 1, so it's just 5 times 1 is 5. But if you think about that for a second, this is, again, a straight line graph. Okay, it's the graph of y equals 5x, y equals mx plus c, if you want to think about it that way, and it has a constant gradient. Its gradient is 5, therefore the derivative function is just 5 all the time. Okay, the gradient is 5 everywhere on that graph, therefore it's 5. Right. Okay. Now let's also look at, what if you had just the number f of x equals, like say number 10, just 10. No x next to it. There's no x at all. Well, if you think about it, if you think about it in the sense of y equals 10, right? Okay, y equals 10. Well, what kind of graph is f of x equals 10 or y equals 10? Well, it's just a horizontal line, isn't it? It's just a horizontal line at 10 on your graph, okay, 10. And what's the gradient of a horizontal line? Well, it's just 0, yeah? So its derivative function is just 0. So if it's a number on its own that's got no x next to it, then it's just 0 gradient, okay? Because it's just a flat line. Or if you want to think about it this way, f of x equals 10, what we could technically write next to it, we could technically write x to the power 0, couldn't we? Because x to the power 0 is 1. So that would just be 10 times 1, and 10 times 1 is just 10. And then if you think about the principle of the derivative function, and so how you get, the steps involved to get the derivative function, the power comes down, and if you think about it, timesing that 10, 0 times 10 is just 0. And there you go, and 0 times anything else is just 0, so that's the derivative function. Well, let's look at doing, okay, let me do some further examples. Okay, let's take something a bit more complicated, right? Let's take something along the lines of f of x equals 6x to the power 5, okay? 6x to the power 5, right, what's its derivative function? Right, first of all, the power comes down, and because there's a number in front of that x, it multiplies it. So it's 5 times 6, which is 30. And then take 1 off that power, so it becomes x to the power of 4. So 6x to the power of 5, its derivative function is 30, 5 times 6, 30, x to the power of 4. Right, let's look at some more. F of x equals, let's go over the top, x to the power, 7x to the power of 4, take away 3x squared, plus 8x to the power of 9, plus 3x plus 12. Alright, let's do that, okay? Right, and when you have something like this, all you have to do is, it's quite simple to work out its derivative function. All you need to do is differentiate each bit. So start with the first one, right? Okay, its power, the x has got a power 4. Multiply the 7 by that, that's 28. And then take 1 off the power, that becomes 3. So it's 28x to the power 3. Right, then this one, okay, so that minus, remember, belongs to the 3. The power is 2, it multiplies that, so you get to take away 6, minus 6. And then what happens to the power? You take away 1 off it, and so you get a power 1, or x to the power 1, but do we need to write 1 as the, if it's x to the power 1? No, we don't. So rub that out, so it's x, so it's minus 6x. Okay, moving on to the next one. Right, okay, we've got a power 9 times that 8, so you have a 72, and then x to the power, take 1 off that power, you get an 8, so 72x to the power of 8. Right, what happens here? That's technically a power 1, and the 1 times the 3 gives you a 3, and then it becomes x to the power of 0, but x to the power of 0 is just 1, so it becomes 3 times 1, which is just 3. So this one just differentiates to 3. What happens to any number that's on its own, that has no x's next to it? Well, it's just 0, okay, plus 0. But do we need to write plus 0? No, we don't. Okay, so this complicated function, its derivative function is this. 28x to the power 3, take away 6x, plus 72x to the power 8, plus 3. And that's it. That's the derivative function there. Alright, so remember that principle, okay? So just remember that principle. If you want to think about it in sort of algebraic form, this is the kind of thing you'll see in your formula booklet. If you had something like f of x equals ax to the power of n, okay, in general, right, so n's some power, a is just some number, its derivative function is, okay, the power multiplies the a, so it becomes a n, and then x, and then you take a 1 off the power, n take away 1. Okay, so that's kind of like the general template to follow. Okay, and then when you have something that's really over the top like this, just differentiate each little component and write it down, and then you've got your derivative function. Okay, don't get these two mixed up. F of x, derivative function, f dash of x. Okay, and that's it for now. In the next clip, we'll look at more funnier examples, things along the lines of negative powers, square roots, and that sort of thing. Okay, so I'm going to stop there.